Okay, now let's take in the robot operating system or ROS as a programming perspective. And mostly I'll assume that you will be relying on the ROS tutorials available at the website, which is extremely handy in order to start and know how to work. I'll still just maybe try run a few examples so that you know how do we program in ROS and how do we run the program in a nice video sense. So after installing ROS, which is of course a Debian installation on an Ubuntu, mostly what you'll be doing, you create a Ros workspace, details given in the Ros tutorials, and that's what it looks like. And SRC is where all my projects will be into. So these are two examples that I'll be taking today, and I've already added them up over here. Conventionally, of course, you do exactly the same thing in multiple platforms where there are GUI tools. The only change that happens over here is that mostly we'll be relying on command line. So that's my workspace where all my projects will be into. After compilation and installation, they'll go into build and devel, and the executables will go there. And each of my project will have source files, and it'll have other information as necessary. The CMake list is, of course, I'll be using Catkin in order to compile and run my program. So any file that you add, any project that you add, it actually needs to be added in your CMake list, which has all the details about all the compilation instructions over here. So let's get started. Let me go into my workspace, and inside that my first example that I will be taking, let's show you what files I have over there. My first example taken as it is from the ROS tutorial. So what does it do? Of course, I'll be making use of a lot of ROS functions which are there at this header type, and I will be making a publisher and a subscriber exchange string information. So that's my string header type. Now remember, the raw string maybe is actually different from a standard C++ string, because you cannot say C++ string is same as Python string. It's a different system. So it needs to be transmitted in ROS TCP, and therefore the headers are important over here. And that's a very small program, which is my main. The first thing that I will have to do is, in order to call all the ROS function, I'll need a reference to a node handler. So whenever I interact with ROS, I'll be doing through this node handler. Then what I do is I advertise myself. I let everybody know that I am opening a new Twitter account, I'm opening a new Instagram account, I'm opening a new topic with the name of topic 1, of course. And the maximum queue size could be 1000, which is over here. We talked about queues before. And I advertise it using the node handler over here. What does it mean is that my event manager now knows that there's a new topic which is created, and this new topic will be used by this particular node. So every script, every program is a node. So it'll be used by this node in order to send information. What I do is I just send hello world 1, hello world 2, hello world 3, and therefore you have a count over here. ROS OK, it just checks whether the ROS server is running. If it's not running, that means you just exit everything and your program terminates. So programs are infinite loops. Every simulation is an infinite runner. Robot keeps on running. So you just check whether your server is running or not. Then of course I said that a C++ string and a Ros string is different because Ros strings need to go over communication protocols, headers. So over this topic, I'll send a Ros string, or this is the message that I'll send over this topic. So I create a message of this type, and then of course I put in hello world and the count string stream the standard way in C++ to do that. And then the message has a header part and the data part. Like any packet, like any message that flows over a network, I only need to, the header is automatically initialized. I only need to set the data part of it. So I say that whatever are the string contents over here, hello world 1, hello world 2. This is a standard way how you convert integers to strings in C++. And then I log this information. So that's a logging utility. So whenever I need to log, I log it. Logging can be at the error level, fatal level, and any of the level. This one is the easiest or the lowest level, that's called as information level. So I log it to the information level, and then of course this was my variable where I had to publish. So I publish it on the same variable. I send data on the same variable. So what does this loop do is it sends hello world 1, hello world 2, hello world 3, hello world 4 multiple times, and it sends it at this channel. So it's topic handler dot publish. The spin once is used when you have callbacks registered, which is when one string has which is when you are acting as a publisher and a subscriber at the same time. This makes sure that for whatever data you were interested in, if a new data has come, the control of the program will be given. So it's callback aware. We don't need it here. And then of course, if I keep on writing on the network channel at such a high rate, problems will happen. So I sleep for some time, where the time I sleep for is called as Ros rate. So what this will do is, using timestamp, it will ensure that my program works at approximately 10 hertz or 10 times a second. So what that means is that this entire program should take 0.1 seconds, or this part of the program it takes 0.01 seconds, so it will sleep for 0.09 seconds, so that the entire program, the entire loop is on at 0.1 second. And then of course I increase my count. The init is argv is used for remapping. So the last lecture was about many times when calling this program, I will have to have remapping. So topic 1 can be renamed to something else. So that's what you do in init. You'll register all the remappings over here, and that's why whatever argv you get, where all the remappings will be executed, you name that up. And this is the name that I will have for this node. So every script is a node, and therefore nodes will have a name. That's what is the name of the node. So let's do one thing. Let's directly run this program up. So I'll first need to compile it. So I use the catkin functionality. So that's the catkin make that's compiling it up. I need to install it up. So there was a devel, and a compilation automatically creates a shell script for different environments so that you can just install that up. So I'll run the setup file. So let's run this thing up so that I can install it. So I've compiled it, I've installed it up, and of course mostly you will include this thing in your .bash rc, so that whenever you open a terminal or whenever you power on your system, the installations can happen automatically. So you add that in the .bash rc file. Now let's run it. Now normally if a program is installed, you just need to write down the name of the program and enter. That's because it's already installed. However, here it's installed specifically as a ROS package. So I'll first enter into ROS. So it's a ROS run command. Now this is exactly what I should have done, but then multiple files will have variable naming conflict. So the way to run it is always the package name. The package name is specified when you create this space, which I had already done, and then the program name. So let's do that up. In my case, the project name is example1, that's the package name, and inside that I've called my program as the publisher. Okay, now if I just do this, okay, I forgot to run the ROS server. So in one terminal, let me just run the ROS server. It's called as ROS core. That's a terminal which will run the ROS server, and I'll not close it ever as long as I'm working with ROS. So let me run it. So you can use tab and it'll autocomplete. And that's what it's doing. It's just publishing on a topic. Let me verify it up before I do anything over it. Let me verify whether what I'm saying is correct. So I first go with, I ask ROS server question. I say ROS node list. So tell me about all the nodes which are active. Remember, I called my node as stalker. So yeah, this node is active. And why is there a slash? Because the variable namespaces conventions. So in C++, if you have to do cout, you say std scope resolution operator cout, because that's the namespace. In ROS, the namespaces are by slash. So it's slash namespace A slash namespace B. That's why a slash. So that's okay. If you just want to find out what all you can do all those things. You can have info of it. And here also I can basically use tab. So talker, it says that it publishes to ROS out because of the logging utility, and then it publishes message to topic one. It does not subscribe to anything, so that's a node which only puts data onto a topic. It's like the celebrity who only publishes, who does not listen to anybody. So the subscriptions are null, and it only publishes things up. There are only logging services, though there's actually no this thing. There's a unique identifier, of course, which is the process ID. And it'll give you all those information. So it's using TCP ROS for communication. Let's go to the topic as well. So how many topics are active? So these are standard, the logging utilities, and there's only one topic, which is topic one, which is active. So topic one is active, and this is the same topic that I had created here. So now it's active because I've run the program. Let's see what is going on in the topic. So again, if you want more information, you can just double tap. So let me echo to find out what is happening. Right now there's nothing going on, so I can just double tab and the same thing comes. So ROS topic echo tells me what all is happening and what topic is going on in that data. I can actually get more information over it. So if I do a ROS topic info topic one, I get who is publishing to it. Currently there is nobody who is subscribing to it. So let me echo it here. So now there's this one utility which is subscribing to it. Otherwise, how am I printing this data? Because there's a utility which is subscribing to it, and because this utility is subscribing to it, so you say that this program talker is the publisher, and this terminal, which has a random name because I did not give any name to this terminal, so that's a subscriber to that topic. And if you want, you can, spelling mistake, you can do all the kind of things, like you can find out at an average at what time is it, I mean, what's the nominal rate. Remember, I had set it to 10 hertz, and it mostly keeps 10 hertz. It cannot be extremely exact. You don't have atomic clocks to measure all this thing up, even if it's exact. So that's all things that you can do about the topics. And I don't want to echo it up over here. And let me stop this program from running as well. I won't stop the server. Now let's make in a subscriber. So all I do is again the same thing, that I'll be making use of Ros functions. I'll be consuming string data. So again, I init argc if there were any remappings. Currently there were none. This will be the name of the topic. I have to interact with my Ros master, my Ros server, my event manager. So I say that I need a handle to it, which will be by n, and then I subscribe to one or more topics. So currently I subscribe to this topic. 1000 is the maximum queue size that will be possible. After 1000 messages, it'll stop. And it'll delete the older messages and take the new one. So I'm subscribing to topic at 1000 messages, and then whenever a message comes here, this function will be automatically called, and then I do nothing. Spin is just to do two things. One is, if I don't include spin, this is just a registry. The registry will happen, return 0, it will return, and then this node will terminate. So I need to have an infinite loop over here. That's one thing which is spin. Secondly, spin is callback aware. So whenever a message comes, the program goes over here and it receives the message and does all this thing. So spin is callback aware, unlike an infinite loop. And then I just log that I heard this thing. So again, message has two parts, the header and the data. I'm only interested with the data part. This will be a raw string. It's not a C++ string. So I convert a raw string into a C++ string using C_str function. So let's run that up. It's already compiled, so I don't need to compile it up. If you want, let me compile it once more. I did not change anything. Let me install it up. I did not do anything, so I need to run. Now remember, what's happening is it's reading from a topic, but I closed the publisher, so nobody is publishing to that topic, so it's not getting anything up. I can still do a ROS node list to verify that this list is running. Yes, it's running. You don't see anything over here because it's subscribed to a topic over which nothing is happening. So I can do info. But then of course what I'll do is more. Let me publish a topic, and what I can do, instead of calling the publisher, I can just publish a topic using command line. So I say ROS topic publish / topic1, and just double tab, you'll get the standard thing. And let me publish a random topic. So I published something from here and it went here. If you want to publish it like multiple times, you add a I think the size is good. So if you want to publish it multiple times, you'd say ROS topic publish. On which topic do you need to publish? On topic 1. What do you need to publish? Just double tab, you'll get I want to publish triple ITA and at the rate of 1 hertz. So this keeps publishing and this keeps getting. Now if you want to do a Ros topic info topic 1, you see that it's handling strings, and this random name, which is this terminal, is a publisher, and this listener, which is what I registered over here, I called it as a listener over here, is what is the subscriber. So that's going up, that's going okay. Now let me have a symphony between the publisher and the subscriber. Let me close everything up. So I run a example 1 publisher here, it's publishing, and I run a subscriber here. So this is publishing, this is subscribing, and whatever it's publishing, it's subscribing exactly that. Let's look into Ros topic info. So I need to find out what is happening with this topic. So topic 1, talker is publishing to it and listener is subscribing to it. You can actually get messages about what is this string. So that's a message. So I say Ros MSG show. So I say what is the type of this thing. And you actually get that, I mean, there's just a string data associated with this message. So that's Ros MSG show. And let me look at the Ros graph using a GUI, and that's exactly what you see, that this is publishing, this is subscribing, and that's what it is shown over here. That talker is publishing to topic 1 and this is subscribing to topic 1. Let's do a Ros topic echo. And let's look at the RQT graph. So now you see exactly the same thing, that the talker is publishing to topic 1 and topic 1 is going to places. One is the listener one, which is this node that I made, and the other one is a random name, which is this Ros topic echo, which is this Ros topic echo. So it's printing all the data, and the complete information is very interestingly, very nicely shown like this over here. That's the same Ros topic that the Ros graphs that I was calling a few minutes ago. There's another tool that sometimes gets useful, and that's RQT. So that was a RQT graph, and this one is the RQT console. So remember, I was logging things, and this becomes your database, and I was logging it with severity of info, the node, the time, and everything. So all these things are over here. You can actually sort them out, you can export them, you can do all those things. So imagine robots running and the logging utility, the logging database is being made as this happens. So that's the RQT console.